This is an instructional video about solving equations. And our essential question is, what does isolate mean? So, first off, how do we model equations? And this can help us when we have positive values, but when we have negative ones, the it tends to change a little bit. So the rectangle usually stands for your variable, and then the little square will stand for 1. So for example, say that I have this model here and we have this balance beam and it's equal, so that tells me that everything that's on this side is balanced with what's on this side. Say for example, I have 2 rectangles and a square and then 5 squares on that side. This is 2x plus 1 equals 5. And our whole goal is to always figure out what our variable is equal to when we're doing these equations. Now, if you look at this one specifically, the way we can use the model is, well, it's balanced right now. Is there anything that I can take away and it'll still be balanced? Yes, I can. I can take away 1 from each side. And then notice how I have 2 rectangles and 4 squares, so I can regroup it. So I took away 1 from both sides. And now I still have 2 rectangles and 4 squares, and I want to group it. Well, I know that I can group 2. So you end up getting that one of the variables is equal to 2. And you can see that physically, too, if you even grouped it. Like there's one group of 2, and there's another group of 2. Unfortunately, once we start going into negative numbers, it's not going to be as easy as that. And so, the model is helpful to kind of start to visualize it a little bit and really hone in why we're doing inverse operations, because physically I did take away and physically I did group everything. However, what happens is that when we get negatives, we tend to, it does work with negatives too, but it gets a little bit more complicated. And so we really want to focus on trying to make sure that we understand how to use inverse operations, because that really, really pushes in the idea of the balance of the equal sign, which is a huge piece that 7th graders need to know. And as they move on with algebra and they're solving, we need to make sure that we always know that the equal sign means that it's balanced, and we need to always make sure that we honor that. So, what is the order to solve equations? Now, I'm hoping that, and I really am not a big fan of it. However, this is something that can easily help some students. Maybe they remember from elementary school PEMDAS. That was a way to teach the order of operations. So you first do your parentheses and your exponents, then you do your multiplication, division, then your addition, subtraction. So something that I know a lot of teachers will use something called SADMAP. So literally it's the reverse of the order of operations. And that's a way to think through, how do I find my variable? Basically, I have to do everything in reverse. So say, for example, I had negative 3x minus 1, and that is equal to negative 10. Well, I always like to draw a line through my equal sign just so I remember that that's where I'm balancing from. That's kind of my clue piece, like your physical balance here. So I always draw a line through the equal sign, like knowing that that's the road that I have to cross. That's my balancing piece. So then I kind of go through this list. Do I see any subtraction? I do. So I need to do the inverse of that. And inverse just means opposite. So the inverse of multiply is divide. The inverse of subtraction is add. So I'm going to add 1 to both sides of the balance beam. Not to every single thing, but on both sides of the balance beam. Now, negative 10 plus 1 gets me negative 9. What happens here, and like you could see up here, when I took 1 away, it just went away. So these zero out. So way to think about it, you can draw a giant Z. It zeroes out. It just disappears. But I still have negative 3x. Now, do you see any addition? No. Do you see any type of division? No. Do you see multiplication? Yes. Touching means times. And I know that's a little iteration that some students like to use. So right now I have negative 3x. 3 times x equals negative 9. And I know a lot of students can do mental math with this, but I promise you that you really, really, really want to focus on using the inverse operations and modeling it like this, because when we get to more complex problems, it's going to be a lot more efficient to not use mental math. So I'm going to divide by -3 because that's the inverse of multiplying by -3. This technically becomes just 1, but I'm going to just tell you that it zeroes out just so we build the habit of when I have something and I undo it with its opposite, it goes away. -9 divided by -3 gets you +3, and there's our final answer. And then what you do is you always check. So -3 times 3 minus 1, does that equal -10? That's going to give you -9. That's going to equal -10, -10. We're good to go. And I'll show you my checking down there too. So that's typically what we do when we're solving equations. Now we're going to start getting to more complex equations where we have combining like terms, where we have variables on both sides, where we have some distributive property. But this is just kind of the basics of what we do when we're solving equations.